And now in this lecture we'll answer on two questions. In the first question we find out the length of this tangent MF is equal to x. In the second question we find out the length of this tangent AP that is also equal to x. So let's start with the first question. In the drawing we have three identical circles. We have also the big tangent ABC. Tangent ABC is tangent to this circle at point A. It is tangent to this circle at point B, and it is tangent to this circle at point C. In addition, we have the common extent point M. From this common extent point M, we have tangent MD that is tangent to this circle at point D, and the length of tangent MD is 5 units. In addition, from the same common extent point M, we have tangent ME that is tangent to this middle circle at point E. The length of tangent ME is 7 units. And finally, we have tangent MF that is tangent to this circle at point F. The length of tangent MF is x. And our mission is to find out the value of x. Or what is the length of tangent MF is equal to x. So first of all, we define the center of this circle. This point is point P. And we define the length of this, the center of this circle. This point is point Q. We define the center of this circle. This point is point S. In the next step, we join points P and D together by a straight line. Point P is the center of the circle, point D is the point of the circle itself, therefore PD is the radius of this circle. We define the radius of this circle as R, so PD equals to R. Because of the fact that all those three circles are identical, the radii of the other two circles must be also equal to R. And because of the fact that the radius PD of this circle, the radius PD is equal to R, the radius PD is drawn to point D, that is the point of tendency of tangent MD with this circle. And whenever you have a radius that is drawn to the point of tendency, whenever you have a radius that is drawn to the point of tendency, then tangent MD will be perpendicular to the radius DP. If MD is perpendicular to DP, it means that this angle equals to 90 degrees according to rule 1. In the next step, we will join points M and P together by a straight line. By joining points M and P, we get the right triangle MPD. So we'll implement the Pythagoras theorem for this right triangle MPD. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle MPD, MP squared, that is the square of the hypotenuse, is equal to PD squared plus MD squared. And again, in the right triangle MPD, according to the Pythagoras theorem, MP squared equals to PD squared plus MD squared. MP is the missing side, so we leave it as it is, so it is MP squared and it is equal to PD squared. PD is R, it is the radius of this circle, therefore PD squared is R squared plus MD squared. MD is 5, therefore MD squared is 5 squared, that is 25. So in total, according to equation 1, we should find out that MP squared equals to R squared plus 25. We repeat on the same process on this middle circle. That is to say, we join points Q and E together by straight line. Point E is the point of tendency of tangent ME with this circle. So QE is of course the radius of this circle, that is equal to R. And because of the fact that the radius QE is going to point E, that is the point of tendency of tangent ME with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent ME will be perpendicular to the radius EQ. If ME is perpendicular to EQ, it means that this angle equals to 90 degrees according to rule 1. In the next step, we will join points M and Q together by straight line. When joining points M and Q, we create the right triangle MQE. So we'll implement the Pythagoras theorem on this right triangle MQE. According to the Pythagoras theorem, on this right triangle MQE, MQ squared, that is the square of the hypotenuse, is equal to QE squared plus ME squared. Repeat again, in the middle right triangle MQE, according to the Pythagoras theorem, MQ squared equals to QE squared plus ME squared. MQ is the missing side, so we leave it as it is. So MQ squared equals to QE squared. QE is R, therefore QE squared is R squared plus ME squared. ME is 7, therefore ME squared is 7 squared, that is 49. So in total, according to equation 2, we shall find out that MQ squared equals to R squared plus 49. We repeat on the same process on this circle. That is to say, we will join points S and F together by a straight line. SF is of course the radius of this circle, that is R. And because of the fact that the radius SF is drawn to point F, that is the point of tendency of tangent MF in this circle, and whenever your radius is drawn to the point of tendency, then tangent MF will be perpendicular to the radius FS. If MF is perpendicular to FS, it means that this angle equals to 90 degrees according to rule 1. In the next step, we will join points M and S together by a straight line. MS is the hypotenuse of the right triangle MSF, so we implement the Pythagoras theorem on the right triangle MSF. According to the Pythagoras theorem, MS squared, that is the square of the hypotenuse of the right triangle MSF, equals to SF squared plus MF squared. Repeat again, according to the Pythagoras theorem, in the right triangle MFS, MS squared equals to MS squared equals to SF squared plus MF squared. MS is the missing side, so we leave this it is, so it is MS squared that is equal to SF squared. SF is R, therefore SF squared is R squared plus MF squared. MF is X. X is the variable that you are looking for in this question. So MF is X, therefore MF squared is X squared. So in total, according to equation 3, we actually found out that MS squared equals to R squared plus X squared. The 3 points Q, the 3 points P, Q, and S are the 3 centers of those 3 circles. and because of the fact that those 3 points P, Q, and S, they are at the same distance from the straight line ABC, therefore those 3 points P, Q, and S, they are all on the same straight line. Yeah, because of the fact that the 3 points P, Q, and S, they are at the same distance from the straight line ABC, they must be located on one straight line. So PQS is one straight line. Actually, we know that the distance of the 3 points P, Q, and S from the straight line ABC is R, because the distance of point P from the straight line ABC is PA, and PA equals to R. There is distance of point Q from the straight line ABC is QB, and QB equals to R. And finally, the distance of point S from the straight line ABC is SC, and SC is also R. And exactly for the same reason that those 3 points that are located on the straight line PQS, those 3 points P, Q, and S, they are at the same distance from the straight line ABC. It means that the straight line PQS must be parallel to the straight line ABC. Okay? Because we found out that the straight line PQS is parallel to the straight line ABC. We join points P and A together by straight line. Again, PA is the radius of this circle. That equals to R. And because of the fact that the radius PA of this circle that is equal to R, the radius PA is 1 to point A, that is the point of tendency of tangent ABC with this circle. And whenever you have a radius that is 1 to the point of tendency, then tangent ABC will be perpendicular to the radius AP. If ABC is perpendicular to AP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points Q and B together by straight line. QB is of course the radius of this circle, that is R. And because of the fact that the radius QB is equal to R, the radius QB is 1 to point B, that is the point of tendency of tangent ABC with this circle. And whenever you have a radius that is 1 to the point of tendency, then tangent ABC will be perpendicular to the radius BQ. If ABC is perpendicular to BQ, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. And finally, we join points S and C together by straight line. SC is of course the radius of this circle, that is equal to R, again according to the same rule, rule 1, because of the fact that the radius SC is 1 to point C, that is the point of tendency of tangent ABC with this circle, and whenever you have a radius that is 1 to the point of tendency, then tangent ABC will be perpendicular to the radius CS. If ABC is perpendicular to CS, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. Because of the fact that the straight line PQS is parallel to the straight line ABC, we can implement here rule 17. So repeat quickly on rule 17. According to rule 17, the sum of one-sided interangles between two parallel lines is equal to 180 degrees. So in the moment we have line A that is parallel to line B. The red line is line C that intersects with the two parallel lines A and B at those 2 points. So here we have those 2 angles, alpha and beta. Those 2 angles, alpha and beta, they're defined as one-sided interangles. Now, one-sided angles because of the fact that both of them are located on the left side of the straight line AC, and they are interior angles because of the fact that those two angles, alpha and beta, they are both located inside the straight lines A and B. And so in total, they are defined as one-sided interior angles. And according to this rule 17, the sum of two one-sided interior angles is equal to 180 degrees. That is to say, angle alpha plus angle beta is equal to 180 degrees according to this rule 17. Likewise, those two angles, 2 and 1, they are also defined as one-sided interior angles, and according to this rule 17, the sum of those two angles is equal to 180 degrees. That is to say, angle 2 plus angle 1 is equal to 180 degrees. We can implement rule 17 in our drawing. Why? Because in our drawing, we have those two angles, they are defined as one-sided interior angles. And according to rule 17, the sum of those two angles is equal to 180 degrees. So this is the right angle plus this missing angle. In total, they must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size, according to rule 17. Likewise, those two angles are also defined as one-sided interior angles. And according to rule 17, the sum of two one-sided interior angles is equal to 180 degrees. So this angle equals to 90 degrees in its size, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. Likewise, those two angles are also defined as one-sided interior angles. Therefore, the sum of those two angles must be equal to 180 degrees. So this is the right angle plus this missing angle. In total, they must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. And finally, those two angles, they are also defined as one-sided interior angles. And according to rule 17, the sum of two one-sided interior angles is equal to 180 degrees. So this is the right angle plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size, according to rule 17. So in total, inside quadrilateral PQBA, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be a rectangle if not a square. So related to this quadrilateral PQBA is a rectangle because it has 4 right angles. So this is quadrilateral PQBA, and it is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle PQAB, side AB must be equal to the opposite side PQ, but AB is 3 units in its length according to what is given as the question. Therefore, PQ must be, the opposite side PQ must be also equal to 3 units in its length. Likewise, inside quadrilateral QBCS, inside this quadrilateral we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this rectangle not a square. So we relate to this quadrilateral QBCS as a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle SQBC, side BC must be equal to the opposite side QS. But BC is 3, therefore QS must be also equal to 3 units in its length. In the next step, I'll copy the big triangle MSP in a new page, and we'll analyze this big triangle MSC. You should remember that PQ equals to QS, and PQ equals to 3, and QS also equals to 3. So actually, this is the right triangle MPS that I copied from the original drawing. Here we have line segment MD. Line segment MD is defined as the median of this triangle MPS. So write it down. Line segment MD is the median of triangle MPS. So what is a median of a triangle? A median of a triangle starts from the vertex of the triangle and ends at the midpoint of the opposite side. So the median MD starts from the vertex M and ends at the opposite side of this vertex, that is PS. And the median MD bisects side PS. That is to say, it divides the opposite side PS into two equal parts. The first part is PD and the second part is DS. So PD equals to 3 and DS also equals to 3 units in its length. Actually, we have a special formula for the length of the median MD. So I present to you the special formula and we calculate the length of the median MD according to the new formula that I will present to you. Actually, in the drawing we have triangle ABC. The length of side AB is B units, side AC equals to C units in its length, and side BC equals to A units in its length. Here, line segment AD is defined as a median of this triangle ABC. It starts from the vertex A and ends at the midpoint of BC. That is to say, it ends at the opposite side of the vertex A. The opposite side of the vertex A is BC. So the median AD bisects the opposite side BC. That is to say, divide this into two parts. The first part is BD and the second half is DC. And BD also equals to DC. So the median of a triangle bisects the opposite side. It starts from the vertex and it bisects the opposite side of the vertex. Okay? So according to the new formula, the length of the median AD is equal to the square root of 2b squared plus 2c squared minus a squared over 2. Again, the length of this median AD is equal to the square root of 2b squared plus 2c squared minus a squared over 2. Okay, so we can calculate the length of the median MD of this triangle MPS according to the new formula. Actually, the length of the median MD according to the new formula will be equal to the square root of 2 times MP squared plus 2 times MS squared minus PS squared divided by 2. So here we will multiply this equation 1 by 2, and actually the median starts from the vertex M and ends at point Q, and it bisects side PS. That is to say, it divides side PS into two halves. In total, PS equals to 6. So the median MQ divides side PS into two halves. The first half is PS, that is 3 units, and the second half is QS, that is also 3 units. So at point Q, the median MQ divides side PS into two halves. The first half is PS, that is 3, and the second half is QS, that is also 3. So the median is MQ. Okay, the median is MQ in the original drawing. So the length of the median MQ is equal to the square root of 2mp squared plus 2ms squared minus ps squared over 2. Again, mq equals to the square root of 2mp squared plus 2ms squared minus ps squared over 2. So here we'll multiply this equation 1 by 2, and we get that according to equation 1, 2 times mq equals to the square root of 2mp squared plus 2 times ms squared minus ps squared divided by 2. Actually, we multiply it by 2, so 2 will get cancelled. So after we multiply this equation 1 by 2, we actually found out that mq equals to the square root of 2mp squared plus 2ms squared minus ps squared. That's it. So here we'll square both sides of this equation 1. So 2mq squared is 2 squared, that is 4, plus mq squared. So in total 2mq squared is 4mq squared. And because of the fact that the square and the root are two opposite operations, when we square the root, the square will cancel the root, and we're left only with 2mp squared plus 2ms squared minus ps squared. And again, we squared both sides of this equation. So in this side of the equation, the square will cancel the root, and we're left only with what is inside the root. It is 2mp squared plus 2ms squared minus ps squared. So according to equation 1, 4 times mq squared. mq four times mq squared. But mq squared is r squared plus 49. Therefore, we substitute mq squared here by r squared plus 49, and it is equal to 2 times mp squared. But mp squared according to this equation 1 is equal to r squared plus 25. Therefore, we substitute mp squared here by r squared plus 25 plus 2 times ms squared. So it is 2 times ms squared. ms squared according to equation 3 is equal to r squared plus x squared. Therefore, we substitute ms squared here by r squared plus x squared. And we have also minus ps squared. ps in total is 3 plus 3, that is 6. Therefore, ps squared is 6 squared, that is 36. So in total, ps squared is 36. So minus ps squared is minus 36. So here we'll open the brackets on both sides of this equation 1. And we get that 4 times r squared plus 4 times 49 is 196 equals to 2r squared plus 2 times 25 is 50, so it is plus 50, plus 2r squared plus 2x squared minus 36. So here we subtract 4r squared from this equation 1, so 4r squared will get cancelled. Here we have 2r squared plus 2r squared, that is 4r squared, so they also will be cancelled. So just subtracting 4r squared from both sides of the equation. So 4r squared will get cancelled. So after we cancel 4r squared, in this side of the equation we have left only with 196. And it is equal to, on the other side of the equation, we left with 50 minus 36 is 14 plus 2x squared. So in total, according to equation 1, we actually found out that 196 equals to 14 plus 2x squared. Here we subtract 14 from this equation, equation 1, and finally get that 196 minus 14 is 182, so 182 equals to 2x squared. Here we divide this equation, equation 1 by 2, and finally we get that x squared equals to 182 over 2 is 91, so 91 equals to x squared. So here we take out of this equation, and finally we get that x equals to the square root of 91. The square root of 91 is 9.54 units. That is the answer to the question, which I found out that the length of this tangent MF that is equal to x is equal to either square root of 91 units. In terms of numbers, the length of this tangent MF that is equal to x is equal to 9.54 units. So we finish with the first question. In the next step, I will present the second question, and solve the second question of this lecture. Our mission in this second question is to find out the length of this tangent AP is equals to x. So we have to find out the value of x. In the drawing, we have quarter circle AOB. This is quarter circle AOB. Inside this quarter circle, we have this small circle. The small circle and the big quarter circle touch each other at this point. So we define their touching point. This point is point K. And tangent OB is tangent to this small circle is point Q. We define the center of this small circle, this point is point C. And we join point C and Q together by straight line. Point C is the center of this small circle, point Q is the point of the small circle itself, therefore CQ is the radius of this small circle. We'll define the radius of this small circle as A, so CQ equals to A units in itself. According to our definition, it is the radius of the small circle. And because of the fact that the radius CQ is drawn to point Q, that is the point of tendency of tangent OB in this small circle, and whenever you have a radius that is drawn to the point of tendency, then tangent OB will be perpendicular to the radius QC. If OB is perpendicular to QC, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. In the next step, we join points P and C together by a straight line. Actually, point P is the point of tendency of tangent AP with this small circle, and AP equals to x, and x is the line segment, the value, the tangent that we are looking for in this question. We have to find out the length of tangent AP that is equal to x. So point C is the center of this small circle, point P is the point of the small circle itself, therefore PC is the radius of this small circle, this is equal to units in itself according to our definition. And because of the fact that the radius CP of this small circle, the radius CP is equals to R, the radius CP is drawn to point P, that is the point of tendency of tangent AP with this small circle, and whenever you have a radius that is drawn to the point of tendency, then tangent AP will be perpendicular to the radius PC. If AP is perpendicular to PC, it means that this angle equals to 90 degrees according to rule 1. In the next step, we will join points A and C together by straight line. By joining points A and C, we can get the right triangle, triangle HCP. So in the next step, I'll copy the right triangle HCP in the new page, and we will implement the Pythagoras theorem on this right triangle, triangle HCP. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is the abbreviation for Pythagoras theorem. So this is the right triangle APC that they quote from the original drawing. This right triangle APC according to the Pythagoras theorem, AC square, that is the square of the hypotenuse, equals to AP square plus PC square. So I write it down. This will be equation 1. So AC square, that is the square of the hypotenuse, equals to AP square plus PC square. AC is the missing side, so we leave it as it is. So AC square equals to AP square. AP is x, therefore AP square is x square plus PC square. PC is a, therefore PC square is a square. So in total, according to equation 1, we should find out that AC square equals to x square plus a square. Because of the fact that the small circle touches the big circle at this point K, so the two circles have an interminence between them at point K. That is to say, they touch each other internally at point K. And whenever we have two circles that touch each other internally, you can implement rule 9. So application of rule 9. According to rule 9, if two circles touch each other internally, then the straight line that connects the centers together passes through their touching point. So in the drawing we have two circles. The radius of this big circle is 0 at point O. The radius of this small circle is 0 at point M. And the straight line that connects their centers together is of course the straight line OM. And according to this rule 9, the straight line OM must pass through their touching point, that is point P. Again, the straight line OM must pass through point P, that is their touching point, or O and P is one straight line. Again, O and P is one straight line according to this rule 9. So we can implement rule 9 in our drawing. Well, because in our drawing, we have an interminence between the small circle and the big quarter circle, that is to say they touch each other internally. At this point K. The center of this big quarter circle is 0 at point O. The center of this small circle is 0 at point C. And the straight line that connects their centers together is the straight line OC. And according to rule 9, the straight line OC must pass through their touching point, that is point K. Again, the straight line OC must pass through point K, that is their touching point. OCK is one straight line. Again, OCK is one straight line. So we join points O and C together by straight line. And the straight line OC must pass through point K. So, it is very easy to see from knowing that the straight line OC indeed passes through point K, that is the touching point. What is the definition of line segment CK? Line segment CK starts from point C, that is the center of the small circle, and then at point K, that is the point of the small circle itself. So this is exactly the definition of a radius. Therefore, ck is the radius of this small circle that is equal to a units in its length according to our definition. So ck equals to a. What is the definition of line segment OK? Line segment OK starts from point O, that is the center of this quarter circle, and ends at point K, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, OK is the radius of this quarter circle. So we define the radius of this quarter circle as B. So OK equals to B. Actually, AO is also the radius of this quarter circle that is equal to B unit in its length according to our definition. And OB is also the radius of this quarter circle that is equal to B unit in its length. So we can find out that ck equals to A and OK equals to B. So what is the length of line segment OC or CO? Line segment OC equals in total to OK minus ck. Again, OK minus ck equals to OC. So write it down. The length of line segment OC is OK minus ck. So OC in total equals to OK. OK is the radius of the quarter circle that is B, minus ck. ck is the radius of this small circle that is A. So in total, OC equals to B minus A units in its length. OC equals to B minus A units. So in the next step, I'll copy the right triangle OCQ in a new page and we'll implement the Pythagoras theorem on this right triangle OCQ. Here by PT is the abbreviation for Pythagoras theorem. So here, this is the right triangle OCQ that I copied from the original domain. In this right triangle OCQ, OC squared, that is the square of the hypotenuse, equals to CQ squared plus OQ squared. So I write it down. This will be equation 2. OC squared, that is the square of the hypotenuse, is equal to CQ squared plus OQ squared. OC, the hypotenuse OC is B minus A, therefore OC squared is B minus A squared. And it is equal to CQ squared. CQ is A, therefore CQ squared is A squared plus QO squared. QO is 5, therefore QO squared is 5 squared, that is 25. So in total, according to equation 2, we found out that B minus A squared equals to A squared plus 25. So according to equation 2, B minus A squared is B squared plus A squared minus 2 times A times B and it is equal to a square plus 25. And again, according to equation 2, we can find out that b square plus a square minus 2ab equals to a square plus 25. So here we have a square on both sides of the equation, so a square will get cancelled. After we cancel a square on this side of the equation, we left only with b square minus 2ab. On the other side of the equation, we left only with 25. So in total, according to equation 2, we found out that b square minus 2ab equals to 25. In the next step, we will do a construction, that is to say, from this point C, that is the center of this one circle. So from this point C, we will draw perpendicular on AO. Again, from point C, we will draw perpendicular on AO. So actually, this angle equals to 90 degrees. And this angle also equals to 90 degrees according to our construction. When we define the touching point of the perpendicular from point C and AO, this point is point N. So by doing this construction, we're going to do quadrangle NCQO. Inside this quadrangle NCQO, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this 4 facing angle, in total they must be equal to 360 degrees. According to the rule, it said that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, this 4 facing angle must be equal to 90 degrees in its size. So inside quadrangle NCQO, we have 4 right angles. And according to rule 5, any quadrangle that has 4 right angles must be its rectangle in front of square. So we relate to quadrangle NCQO as a rectangle because it has 4 right angles. So quadrangle NCQO is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle NCQO, side OQ must be equal to the opposite side NC. But OQ is 5 units in its length according to what is given as the equation. Therefore, the opposite side NC must be also equal to 5 units in its length. Likewise, according to the same rule, in the same rectangle NCQO, side CQ must be equal to the opposite side NO, but CQ is A, therefore NO must be equal to A units in its length. What is the ref of the missing line 7? Line 7 AN. From the drawing it is very easy to see that AN in total equals to AO minus NO. Again, AN equals to AO minus NO. So I'll write it down. AN equals to AO minus NO. So AN in total equals to AO, that is B, it is the radius of the quarter circle, that is B, minus NO. NO, just write down found out that NO equals to A. NO equals to A. So in total, AN equals to B minus A units in its length. So AN equals to B minus A units in its length. So in the next step, I'll copy the right triangle A and C in the new page, and we implement the Pythagoras theorem on this right triangle, triangle A and C. Here by PT is the permission for Pythagoras theorem. So actually, this is the right triangle A and C. This is the common from the original drawing. In this right triangle A and C, AC squared, that is the square of the hypotenuse, equals to AN squared plus NC squared. So I'll write it down. This will be equation 3. So AC squared, that is the square of the hypotenuse, is equal to AN squared plus NC squared. According to equation 1, AC squared equals to X squared plus A squared. Therefore, we substitute A squared in this equation 2 by X squared plus A squared. So AC squared equals to X squared plus A squared according to equation 1. And it is equals to AN squared. AN is B minus A, therefore AN squared is B minus A squared. Plus NC squared. NC is 5, therefore NC squared is 5 squared. That is 25. So in total, according to equation 1, according to this equation 3, according to equation 3, we found out actually that X squared plus A squared equals to B minus A squared plus 25. So X squared plus A squared equals to B minus A squared. B minus A squared equals to B squared plus A squared minus 2 times A times B plus 25. So here we have A squared on both sides of this equation, so A squared will get cancelled. After we cancelled A squared, on this side of this equation 3 we left only with X squared. And the other side of the equation 3 we have here B squared plus 2AB plus 25. So according to equation 3, we actually found out that X squared equals to B squared minus 2AB plus 25. But according to this equation 2, B squared minus 2AB is 25. Therefore, we substitute B squared minus 2AB here by 25. And you get that in total X squared equals to, again, B squared minus 2AB, according to this equation 2 is 25. So we substitute B squared minus 2AB by 25. And we have also plus 25. So in total, X squared equals to 25 plus 25, that is 50. So X squared equals to 50. Here we take a root out of this equation and finally get that X equals to the square root of 50. So it is the square root of 50, but 50 is 2 times 25. And the square root of 25 is 5. So in total, this expression equals to 5 times square root of 2. 5 times square root of 2 is 7.071 units. And that is the answer to the question. Actually, we found out that the length of tangent AP is equal to X. So the length is equal to either 5 times square root of 2 units, or in terms of numbers, the length of AP is equal to X is equal to 7.071 units. So we finish with the second question. So in the next step, I will summarize the lecture. We'll start with the first question, of course. In the first question, our mission was to find out the length of this tangent MF that is equal to X. So we have to find out the value of X. So in the drawing, we have 3 identical circles, and we also have the big tangent ABC. Tangent ABC is tangent to this circle at point A. It is tangent to this middle circle at point B, and tangent ABC is tangent to this circle is point C. In addition, we have, this is the common example point M. From this common example point M, we have tangent MD to this tangent to this circle at point D. The length of tangent MD is 5 units. In addition, from the same common example point M, we have tangent ME. Tangent ME is tangent to this middle circle at point E. The length of tangent ME is 7 units. And finally, we have also tangent MF that is tangent to this circle at point F. The length of tangent MF is X. So our mission is to find out the length of tangent MF that is equals to X. So we have to find out the value of X. So first of all, we define the center of this circle. This point is point P. We define the center of this middle circle as Q, and we define the center of this circle. This point is point S. In the next step, we join points P and D together by straight line. PD is of course the radius of this circle. We define the radius of this circle as R, and because of the fact that those three circles are identical, the radius of those two circles must be also equal to R. So PD equals to R, and because of the fact that the radius PD is known to point D, that is the point of tendency of tangent MD with this circle, and whenever you have a radius that is known to the point of tendency, then tangent MD will be perpendicular to the radius DP. If MD is perpendicular to DP, it means that this circle equals to 90 degrees according to rule 1. In the next step, we join points M and P together by straight line. By joining points M and P, we created the right triangle MPD. So we implemented the Pythagoras theorem on the right triangle MPD. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle MPD, the hypotenuse is MP, so the square of the hypotenuse is MP square. So MP square must be equal to PD square plus MD square. So again, according to the Pythagoras theorem on the right triangle MPD, MP square equals to PD square plus MD square. MP is the missing side, so we leave it as it is. So it is MP square equals to PD square. PD is R, it is the radius of this circle that is R, so PD square is R square, plus MD square. MD is 5, therefore MD square is 5 square. So in total, according to equation 1, we found out that MP square equals to R square plus 25. We repeated on the same process on this circle. We actually join points Q and E together by straight line. QE is of course the radius of this circle, that is R. And because of the fact that the radius QE is known to point E, that is the point of tendency of tangent AE with this circle, whenever you have a radius that is known to the point of tendency, then tangent ME will be perpendicular to the radius EQ. If ME is perpendicular to EQ, it means that this circle equals to 90 degrees. In the next step, we join points M and Q together by straight line. By joining points M and Q, we created the right triangle MQE. So in the next step, we implemented the Pythagoras theorem in the right triangle MQE. According to the Pythagoras theorem in the right triangle MQE, MQ squared, that is the square of the hypotenuse, equals to QE square plus ME square. So repeat again, according to the Pythagoras theorem in the right triangle MQE, MQ square equals to QE square plus ME square. MQ is the missing side, so we leave it as it is. So it is MQ square equals to QE square. QE is R, therefore QE square is R square, plus ME square. ME is 7, therefore ME square is 7 square, that is 49. So in total, according to equation 2, we actually found out that MQ square equals to R square plus 49. In the next step, we repeated on the same process on this circle. We actually join points S and F together by straight line. SF is the radius of this circle, that is R. And because of the fact that the radius SF is known to point F, that is the point of tendency of tangent MF in this circle, and whenever you have a radius that is known to the point of tendency, then tangent MF will be perpendicular to the radius FS. If MF is perpendicular to FS, it means that this circle equals to 90 degrees according to rule 1. In the next step, we join points M and S together by straight line. By joining points M and S, we created the right big triangle MSF. So in the next step, we implemented the Pythagoras theorem on the right big triangle MSF. According to the Pythagoras theorem, in this right triangle MSF, MS square equals to SF square plus FM square. Again, according to the Pythagoras theorem, that's in the right triangle MSF. MS squared equals to SF squared plus MF squared. MS is the missing side, so we leave it as it is. So it is MS squared equals to SF squared. SF is R, therefore SF squared is R squared plus FM squared. FM is X, therefore FM squared is X squared. So according to equation 3 in total, we can find out that MS squared equals to R squared plus X squared. In the next step, we join points P and A together by straight line. PA is the radius of this circle that is R, and because of the fact that the radius PA is going to point A, that is the point of tendency of tangent ABC with this circle, whenever your radius that is going to the point of tendency, then tangent ABC will be perpendicular to the radius AP. If ABC is perpendicular to AP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points Q and B together by straight line. QB is the radius of this angle that is R, and because of the fact that the radius QB is going to point B, that is the point of tendency of tangent ABC with this angle, and whenever your radius is going to the point of tendency, then tangent ABC will be perpendicular to the radius BQ. If ABC is perpendicular to BQ, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to the same rule, or 1. Likewise, we join points S and C together by straight line. SC is of course the radius of this circle that is R, and because of the fact that the radius SC is going to point C, that is the point of tendency of tangent ABC with this circle, whenever the radius is going to the point of tendency, then tangent ABC will be perpendicular to the radius CS. If ABC is perpendicular to CS, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. So we have here the 3 points P, Q, and S. Those 3 points are at the same distance from the straight line ABC. Again, the 3 points P, Q, and S are at the same distance from the straight line ABC. Therefore, PQS must be one straight line. Again, PQS must be one straight line. And exactly because of the same reason that the 3 points P, Q, and S are located at the same distance from the straight line ABC, it means that the straight line PQS must be parallel to the straight line ABC. So here we can implement rule 17. So a bit quickly on rule 17. According to rule 17, the sum of one-sided interior angles between two parallel lines is equal to 180 degrees. So in the drawing we have line A that is parallel to line B, and the red line C cuts those two parallel lines A and B at those 2 points. So here we have the 2 angles alpha and beta. Those angles alpha and beta, they are defined as one-sided interior angles, and according to this rule 17, the sum of 2 one-sided interior angles is equal to 180 degrees. That is to say, alpha plus beta equals to 180 degrees. So we can actually implement rule 17 in our drawing. Well, because in our drawing we have those 2 angles that are defined as one-sided interior angles, and they are located between the parallel lines PQS and ABC. And therefore, according to rule 17, the sum of those 2 angles must be equal to 180 degrees. So this is a right angle plus this missing angle. In total, the sum of those 2 angles must be equal to 180 degrees according to rule 17. Therefore, this missing angle must be equal to 90 degrees in its size. Likewise, those 2 angles are also defined as one-sided interior angles, and they are located between the parallel lines PQS and ABC. And therefore, the sum of those 2 angles must be equal to 180 degrees. But this is a right angle. So this angle that is equal to 90 degrees plus this missing angle, in total the sum of those 2 angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. Likewise, those 2 angles are also defined as one-sided interior angles. And according to rule 17, the sum of 2 one-sided interior angles is equal to 180 degrees. So this is a right angle. This is equal to 90 degrees in its size. So 90 degrees plus the sum plus the size of this angle, in total the sum of those 2 angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. And finally, those two angles are also defined as one-sided interangles. This is the right angle, so this angle is equal to 90 degrees plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to Rule 17. Therefore, this missing angle must be equal to 90 degrees in its size. So in total, inside quadrilateral QSCB, we have 4 right angles. And according to Rule 5, any quadrilateral that has 4 right angles must be its rectangle if not a square. So we refer to quadrilateral QSCB is a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle QSCB, side BC must be equal to the opposite side QS. But BC equals to 3, therefore the opposite side QS must be also equal to 3 units in its length. Likewise, in quadrilateral PQBA we have 4 right angles, and therefore it must be a rectangle according to Rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So rectangle PQBA, side AB must be equal to the opposite side PQ, but AB is 3, therefore the opposite side PQ must be also equal to 3 units in its length. In the next step, I copied the triangle PMS. In your page, and we analyze this triangle PMS. Actually, MQ divides side PS into 2 halves. The first half is PQ, this is equal to 3 units, and the second half is QS, this is also equal to 3 units in its length. So actually, this is triangle PMS that I call it from the original domain. We have here MQ is defined as the median of this triangle MPS. Line segment MQ starts from the vertex M and ends at the opposite side of this vertex M, that is PS. And it ends at point Q. Actually, it divides the opposite side PS into 2 halves. The first half is PQ, that is equal to 3 units, and the second half is QS, that is also equal to 3 units in its length. So the median of any triangle bisects the opposite side to the vertex. Okay, the median MQ starts from the vertex M and ends at point Q, that is the midpoint of side PS. And it divides side PS into 2 halves. Each half equals to 3 units in its length. So what is the length of the median MQ? We have a special formula for the length of the median MQ. The length of the median MQ. So we have here triangle ABC. In triangle ABC, side AB equals to B units in its length, side AC equals to C units in its length. This is side BC, this is equals to A units in its length. AD is the median to BC. That is to say, it divides side BC into 2 halves. Each half equals to BC over 2. So the first half is BD, and it is equals to the second half, that is DC. So the question is, what is the length of the median AD? The length of the median AD, according to the new formula, it is equals to the square root of 2b squared plus 2c squared minus a squared over 2. Again, AD equals to the square root of 2b squared plus 2c squared minus a squared over 2. So we can implement the new rule in order to find out the length of the median MQ. The length of the median MQ, according to the new formula, will be equal to the square root of 2 times MP squared plus 2 times MS squared minus PS squared divided by 2. Again, MQ in total equals to the square root of 2 MP squared plus 2 MS squared minus PS squared over 2. Here we multiply this equation 1 by 2, and finally found out that 2MQ equals to 2MP squared plus 2MS squared minus PS squared. We squared both sides of this equation. So the square of 2MS squared is 4MQ squared, because 2 squared is 4. MQ squared is MQ squared, so in total 2MQ is 4MQ squared. And because of the fact that the square cancels the root, so we're left only with what is inside the root, that is 2MP squared plus 2MS squared minus PS squared. So in total, according to equation 1, we should find out that 4MQ squared equals to 2mp square plus 2ms square minus ps square. So we have 4 times mq square. 4 times mq square. Mq square equals to r square plus 49. Therefore, we substitute mq square by r square plus 49, and it is equals to 2mp square. According to equation 1, mp square equals to r square plus 25. Therefore, we substitute mp square here by r square plus 25, and we have also here 2 times ms square. So it is 2 times ms square. But according to equation 3, ms square equals to r square plus x square. Therefore, we substitute ms square here by r square plus x square, and we have also minus ps square. PS in total equals to 3 plus 3, that is 6, therefore PS square is 6 squared, that is 36. So in total PS square is 36. So we have here minus PS square, that is minus 36. We open the brackets on both sides of this equation 1. So we have here 4r square, and 4 times 49 is 196. So in total this side of the equation we have 4r square plus 196. Here we have 2r square plus 2 times 25, that is 50. We have here 2r square plus 2x square minus 36. Here we subtracted 4r square from both sides of the equation, so 4r square here we can cancel, and 2r square plus 2r square is 4r square, so those two expressions are also going to get cancelled. After we cancelled 4r square, in this side of the equation we have left only 196. On the other side of the equation we have here 50 minus 36, that is 14. So in total on this side of this equation we have 14 plus 2x squared. So in total, according to equation 1, we can find out that 196 equals to 14 plus 2x squared. Here we subtracted 14 for this equation 1, and finally found out that 196 minus 14 is 182. So in total 182 equals to 2x squared. Here we divided this equation 1 by 2, and finally found out that 182 over 2 is 91. So in total we can find out that 91 equals to x squared. Here we took out all of this equation and finally found out that x equals to either the square root of 91 or the square root of 91 is equal to 9.54 units. So in total we can find out that the length of this line segment MF or tangent MF that is equal to x is equal to either the square root of 91 units, or in terms of numbers, MF that is equal to x is equal to 9.54 units. We finished with the first question, so in the next step we're presented to the second question, and we solve the second question of this lecture. So our mission in the second question is to find out the length of this tangent AP that is equal to x. Tangent AP tangent to this small circle is point P. So in the drawing we have quarter circle AOB. Inside this quarter circle AOB we have this small circle. The quarter circle and the small circle touch each other at this point. We define their touching point. This point is point K. And we also know that this is line segment QO that equals to 5 units in its length. Again, our mission is to find out the length of tangent AP that equals to x. We have to find out the value of x. So, first of all, we define the center of this circle. This point is point C. We define the point of tangent OB with this small circle. This point is point Q. And then we join points C and Q together by straight line. CQ is the radius of this circle. We define the radius of this small circle as A. We define the radius of this big quarter circle as B. So AO equals to B. OB is also the radius of this quarter circle that is equals to B units in its length according to our definition. In the next step, we join points P and C together by straight line. AP is tangent to this small circle is point P. So point C is the center of this circle, point P is the point of the small circle itself, therefore CP is the radius of this small circle, that is equals to A. And because of the fact that the radius CP is drawn to point P, that is the point of tendency of tangent AP with this small circle, and whenever your radius is drawn to the point of tendency, then tangent AP will be perpendicular to the radius PC. If AP is perpendicular to PC, it means that this angle equals to 90 degrees according to rule 1. In the next step, we join points A and C together by straight line. By joining points A and C, we can get the right triangle APC. So in the next step, we copy the right triangle APC in a new page and we measure the Pythagoras theorem of this right triangle ACP. This is the right triangle ACP, that is according to the original drawing. According to the Pythagoras theorem, in this right triangle ACP, AC squared, that is the square of the hypotenuse, equals to AP squared plus PC squared. AC is the missing side, so unit is it is, and it is equals to AP squared. AP is x, therefore AP squared is x squared, plus PC squared. PC is a, therefore PC squared is a squared. So in total, according to equation 1, we shall find out that AC squared equals to x squared plus a squared. And because of the fact that the small circle touches the big quarter circle internally at point K, we have here an internal arch, and whenever we have an internal arch between two circles, you can implement all lines. So I can click on all line. According to all line, if two circles touch each other internally, then the straight line that connects their centers together passes through their touching point. So when you have two circles, the center of this big circle is at point O, the center of this small circle is at point M. The straight line that connects their centers together is of course the straight line OM. And according to this whole line, the straight line OM must pass through their touching point, that is point P. Again, the straight line OM must pass through point P, that is their touching point. O and P is one straight line. Again, according to this whole line, O and P is one straight line. So we can implement all line in our drawing. Why? Because we have here an internal arch between the small circle and the big quarter circle. So according to all line, the center of this quarter circle is at point O. The center of this small circle is at point C, and the straight line that connects the centers together is of course the straight line OC. And according to rule 9, the straight line OC must pass through the touching point, that is point K. Or OCK is one straight line. So we join points O and C together by straight line, and we extended the straight line OC, and you can see that OCK is indeed one straight line, or the straight line OC passes through point K, that is the touching point, exactly according to all 9. What is the definition of CK? CK is the radius of this small circle, that is A. What is the definition of OK? OK is the radius of the big quarter circle, that is equals to B units in itself according to our definition. So OK equals to B and CK equals to A. What is the ref of OC? OC equals to OK minus CK. Again, OC equals to OK minus CK. So OC equals to OK, that is B. That is the radius of the quarter circle, that is B, minus CK. CK is the radius of the small circle, that is A. So in total, OC equals to B minus A units. So in the next step, I'll complete the right triangle OCQ in the new page, and we implemented the Pythagoras theorem on this right triangle OCQ. This is the right triangle OCQ that I copied from the original drawing. We just right now found out that OC equals to B minus A units in strength. OC equals to B minus A units in strength. So the opposite OC is B minus A. CQ is the radius of the small circle, that is A. And QO equals to 5 units in strength according to what is given as the question. According to the Pythagoras theorem, in this right triangle OCQ, OC squared, that is the square of the hypotenuse, equals to CQ squared plus QO squared. OC is B minus A, therefore OC squared is B minus A squared, and it is equals to CQ squared. CQ is A, therefore CQ squared is A squared, plus QO squared. QO is 5, therefore QO squared is 5 squared. So in total, according to 5 squared, that is 25. In total, according to equation 2, we shall find out that B minus A squared equals to A squared plus 25. In the next step, we did the construction, that is to say, from this point C, that is the center of this small circle. So from point C, we go perpendicular on AO. Again, from point C, we go perpendicular on AO. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point C and AO, this point is point N. By doing this construction, we created the quadrilateral NCQO. Inside this quadrilateral NCQO, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the side of this fourth facing angle in total must be equal to 360 degrees, according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth facing angle must be equal to 90 degrees in its side. So inside quadrilateral NCQO, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be a right angle if not a square. So we relate to this quadrilateral NCQO as a right angle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle NCQO, side QO must be equal to the opposite side NC. But QO is 5, therefore the opposite side NC must be also equal to 5 units in itself. Likewise, according to the sum rule, in the same rectangle NCQO, side CQ must be equals to the opposite side NO. But CQ equals to 8, therefore NO must be also equal to 8 units in itself. What is the length of the missing line 70 AN? From the law, it is very easy to see that AN in total equals to AO minus NO. Again, AN equals to AO minus NO. So AN in total equals to AO. AO is the radius of the quarter circle that is V minus NO that is A. So in total AN equals to B minus A units in its length. In the next step, I commit the right triangle ANB, ANC. In the new page, I represent the Pythagorean next right triangle, triangle ANC. So actually, this is right triangle ANC that I commit from the original drawing. According to the Pythagorean theorem, in this right triangle ANC, AC squared, that is the square of the hypotenuse, equals to AN squared plus NC squared. AC squared, according to equation 1, AC squared equals to x squared plus a squared. Therefore, we substitute AC squared here by x squared plus a squared, and it is equals to AN squared. AN is B minus A, therefore AN squared is B minus A squared plus NC squared. NC is 5, therefore NC squared is 5 squared, that is 25. So in total, according to equation 3, we found out that x squared plus a squared equals to b minus a squared plus 25. So x squared plus a squared equals to b minus a squared. B minus a squared equals to b squared plus a squared minus 2ab plus 25. So here we have a squared on both sides of the equation, so a squared will get cancelled. After we cancel a squared, on this side of the equation we left only if x squared. On the other side of the equation we left with b squared minus 2ab plus 25. But according to this equation 2, b squared minus 2ab is 25. Therefore, we substitute that b squared minus 2ab by 25. And in total, we found out that x squared equals to 25 plus 25. 25 plus 25 is 50. So in total, we found out that x squared equals to 50. Here we took out of this equation and finally found out that x equals to the square root of 50. 50 is 2 times 25. So this expression, and the square root of 25 is 5. So in total, this expression equals to 5 times square root of 2. 5 times square root of 2 is 7.071 units. So in total, we should found out that the length of tangent AP that is equals to x, it is equals to either 5 times square root of 2 units in itself, or in terms of numbers, the length of tangent AP that is equals to x is equal to 7.071 units in its length. Okay, thank you very much.